Welcome to EDU World Space.
We're asked to find the area of the surface obtained by rotating the circle x squared plus y squared equals r squared about the line y equals r. Well, for the upper semicircle, we have the function f of x is equal to the square root of r squared minus x squared. Therefore, it follows that f prime of x this is going to be negative x over the square root of r squared minus x squared. Now the surface area generated, we'll call it S1. This is the integral from negative r to x equals positive r of 2 pi times, and then in reference to a previous exercise, we have c minus f of x, which is the square root of r squared minus x squared, times the square root of 1 plus f prime of x squared, or 1 plus x squared over r squared minus x squared dx. And so we see that we can combine under the radical and get r squared over r squared minus x squared. Also, we see that the function, the integrand, is an even function. So this is the same as 2 times 2 pi, or 4 pi, times the integral from 0 to r of, this is going to be, instead of c, I mean r here, sorry, of r minus the square root of r squared minus x squared times, and this becomes, the square root of r squared is simply r over the square root of r squared minus x squared. This is because r is positive, dx. And then we can write this as 4 pi times the integral from 0 to r of, and we get r squared over the square root of r squared minus x squared minus r dx. And likewise, for the lower semicircle, we have that f of x is equal to negative square root of r squared minus x squared, so that f prime of x is equal to x over the square root of r squared minus x squared. So we have that area of this lower half, S2, is the integral again from negative r to positive r of 2 pi times r minus the square root, or I guess this is r plus square root of r squared minus x squared times the square root of 1 plus x squared over r squared minus x squared dx. We see this is really identical to S1, except for we have r plus instead of an r minus square root of r squared minus x squared. So we'll get the same thing as in S1, we get 4 pi times the integral from 0 to r of, and here we'll have r squared over the square root of r squared minus x squared, and then we'll have a plus r dx. Therefore, total surface area, S, is going to be S1 plus S2, which when we add these together, we cancel out the r terms in the integrands, and so we simply get 8 pi times the integral from 0 to r of r squared over the square root of r squared minus x squared dx. And this can be simplified by taking the antiderivative, so we get 8 pi times the inverse sine of x over r evaluated at 0 and r. And in fact, this is the inverse sine of x over r times r squared out in front. And so we get 8 pi r squared times inverse sine of 1, which is pi over 2, minus inverse sine of 0, which is 0. And so we have 4 pi squared r squared.